Let's get one thing clear about HRM. Even though HRM beat Opus 4, GPT 4.5, and O3 in the ArcAGI benchmark, while only being 27 million parameters in size, we really shouldn't be comparing HRM against these models, and here's why. We know that state-of-the-art models like Claude, GPT, Gemini, and Grok are sized at around 500 billion to 2 trillion parameters in size, which is something that consumers like you and me can never dream about running it locally on our own machine. So when Sapien Research Lab published a paper in June and released a model called HRM in July, people were certainly impressed by how a model that's 1,000 times smaller can achieve better results than its counterparts. HRM scored 32% in ArcAGI 1 and 2% in ArcAGI 2. And the more impressive part about it is that HRM didn't even do any pre-training. And here's a quick review on pre-training. Pre-training is a crucial part in building an LLM where billions and trillions of data is fed into the model to learn. So when you hear phrases like this model was trained with the entire internet, it's really referring to this stage called pre-training, where the model makes auto-regressive prediction based on the large amount of data set that it saw. For reference, Qwen3 Coder, which is a 480 billion parameter model, was trained with 7.5 trillions of tokens during pre-training, and Mikimi K2, which is a trillion parameter model, was trained with 15.5 trillion tokens. Well, in the case of HRM, it had 0. So how is it even possible that HRM can perform so well without any pre-training? The LLMs that we use today are what's known as foundation models. Foundation model essentially means that it was pre-trained on a broad data that can be adapted to a wide range of downstream tasks like language translation, image recognition, or code generation. And this concept of foundation model was coined back in July 22 in a research paper that stated that 2018 was when we entered into an era of foundation models in AI. So by definition, HRM is not a foundation model because it misses two critical things: broad data and transfer learning. For instance, models that we use in ChatGPT, for example, we can ask about pop culture, medical summaries, advanced mathematics, or even legal advice because in the trillions of data that it was fed into the model during pre-training probably included related examples that the model can learn via transfer. So if I asked an LLM to write a homepage for my e-commerce site, the LLM can draw from hundreds and thousands of different examples of e-commerce sites that were included in the pre-training data and generalize it for the task at hand. HRM is incapable of doing something like this because it's not a foundation model that can generalize on tasks. Rather, it has the ability to solve logical puzzles and demonstrate intuition, which is what ArcAGI measures best. In other words, the release of HRM is not to be mistaken as a disruption in the transformer-based models that we love and use today, but it's rather a refinement in AGI where its aim is to simulate human intelligence artificially. So HRM is not an antithesis to scaling law, but rather an architecture improvement in how neural networks could learn. Now that we cleared up some of the confusions around HRM, how does the HRM model actually work? The architecture that was proposed by HRM is inspired by biology, where the human brain has cross-frequency that couples between what's known as theta and gamma neural oscillations. My background, however, is not in neuroscience, so I'm going to take their word for what it is. So I'm only going to focus on the technical portion rather than the biological structure of the brain. So essentially, the core innovation behind HRM is its dual recurrent loop system instead of a classic transformer architecture that we see in commercial models like GPT-5, O3, Claude, and Gemini. These transformer-based models are designed to predict the next token based on the probability of the next word from the previous tokens, whereas HRM makes tokens based on two distinct recurrent neural networks. Essentially, instead of transformers that predict the next word given a phrase, HRM will engage in a quote-unquote thinking or reasoning by making bursts of fast thinking in the lower level module, while also being guided by higher level module that is slower and more abstract than the lower module to iterate its thinking properly. Okay, so what? What's really the significance here? In order to understand why HRM is an important breakthrough, we need to go back to what I mentioned earlier, which is the foundation model. Even back in 2022, when the concept of foundation model was coined, it wasn't certain whether GPT-based models would succeed over other variants like BERT or T5. However, since 2022, we have seen complete dominance in GPT-based models, which are like OpenAI's GPT, Gemini, Claude, and Grok. And the main reason why GPT-based models succeeded the way it did is because it worked really well with scaling, which is why it blew past other architectures like recurrent neural network-based models, as well as other variants like BERT and T5. The problem is, as the GPT-based architecture reached about 1 to 2 trillion parameters in size, the performance started to saturate. And now with HRM's release, we're seeing innovations being made in the recurrent neural network-based models that's showing what it's really capable of in its reasoning abilities, which is something that transformer models are notoriously not good at. So back to the comparison, we can't really compare HRM with GPT-based models because they're completely different architectures that do completely different things. Instead, I think we should be asking the question, can we get back to RNN-based architecture and achieve a better result towards AGI? Personally, I'm glad to see HRM for two main reasons. First, RNNs could potentially be back on the menu over transformer-based models. Since 2022, we have traded off quality of learning for speed of innovation, largely by making the models bigger. And this means that in order to get state-of-the-art level models, there's really no chance that we can run them on our own machine, rather in a large cluster somewhere. But now, the industry seems to signal back to non-transformer based models that could possibly yield better result in its learning mechanism. Previously, recurrent neural networks had a hard time overcoming this, which is early convergence on hidden layers, which basically means the network would settle into suboptimal representation too soon and lose long-term dependencies way too early. And the HRM's architecture essentially bifurcated the architecture into two recurrent neural networks in two different time frequencies that can influence one's bursts of thinking to ensure higher reasoning. However, the big challenge still remains with RNNs in terms of pre-training, which is why in the first place transformers were preferred over RNNs based models, since you can quickly train the models in batch with trillions and trillions of tokens in parallel, and HRM still hasn't solved that yet. The second reason is this: the path to true AGI needs to be reconsidered. It's good to see that HRM was inspired by how human brain actually functions, and as much as transformer-based architecture is extremely effective at what it does, it lacks the ability to truly think and reason, which is a critical feature when we're talking about AGI. All in all, HRM demonstrated that by only using 1,000 examples of data, it was able to show its ability to learn and reason. However, the biggest innovation for this that led to HRM's success seems to be the outer refinement loop, where the model feeds the burst of thinking into lower module by the higher module to iteratively make adjustments for better answers.